Welcome! In this series of videos, we will look at software add-ons for the PowerBasic Windows compiler. Today we will look again at using the MyLotoGrid custom grid without the use of SQL Tools or SQL Server to speed up your application development. This was our PowerBasic Windows application at the end of the last video. In our application, we have a grid displaying 2000 records of data. This data is coming from a flat text file, and the configuration of the grid is also coming from a flat text file. In the last video we added an extra column, the skills column, which is a series of tick boxes. What we're going to do today is add a bit more logic into the event handler of the grid in the callback function to allow the fact that the user has clicked on one of these editable fields and to make it visible on screen that they have indeed done so. Having highlighted to the user that these fields have indeed been amended, the user then has two options. They can right-click and revoke the change, or they can click the Save Changes button on the toolbar. In order to do this, we're going to make use of a feature of the MyLotoGrid control, where you can store a numeric value against any row in the grid. And the second thing we're going to do today is to put some functionality behind the drill down button that we placed in the last video on the surname field. Each time the field is clicked on, a small button appears on the right hand side of the cell. So let's have a look at our code. If we go to the callback function, which is our event handler, we'll see in here we have a number of variables defined at the beginning of this callback function. We're going to set up some new variables in here, which will be used to keep track of what we're going to be doing today. We're going to be using a string variable to pick up the name of a column. We're going to be using a long variable to keep track of our reference within the user-defined type, which keeps track of all the configuration information that defines the grid. And we're going to have three static variables, which will be the numeric values of the form, the grid, and the tab we're actually operating on. As you'll see in the previous videos, we set up a definition inside here and the initialization of the name of the form, the name of the grid, and the name of the tab. And we're going to put three additional lines of code in here to populate the form, grid, and tab numbers. These will be using a function that sits inside our library to pull back the form number from the form name. And since these are static variables, the value of them will persist. So every time we come into this particular callback function, the value will already be there, as it will have been populated when the dialog was initialized. Now that we've got the basics set up, let's have a look at the event handling for the grid itself. We'll find down in the case notify event, we have the handling for our grid control. At the moment, we're handling the right-click menu. This event handles the right-click on a grid and where an item has been picked from the pop-up menu. We're going to be adding two new events. One to pick up the fact that a cell on the grid has been altered, and one to pick up the fact that one of the user-defined buttons has been clicked upon. We'll populate the code behind these two events in a moment, but we already have some logic in the application to allow us to sort the column. Now the last thing we want to do is to sort the column while the application is doing something else in the back end, so we're going to set a constant that we've got set up to record the fact that we're in the process of sorting. We can test this later on in the code to make sure that nothing's done while the sorting algorithm is actually running. So having done that, let's handle the user button first. So a user has clicked on one of the cells which has one of the user-defined buttons. So when the user does click on a user-defined button, then this event will be triggered. Inside here, we can pick up the row and the column that the user has indeed clicked on. Armed with this information, we can then pull the value that sits inside the cell that the user has clicked on by using the MLG get command, which is a function within the MyLotoGrid library. It takes three simple parameters: the handle of the grid, the row that the user has clicked on, and the column the user has clicked on. And whatever text value sits within that will be populated into the column data variable. We can then display this on the screen. So if we try running this code now, and we click on a surname field and then the drill down button, we will get a pop-up message box with the value in that cell. So if we try a different one, we'll get that value up. So you can see we've now put an event in which triggers when the drill down button has actually been clicked. With any of these grids, there really must be a way of defining which is the unique identifier for the record you have actually clicked on. In our currently configured grid, this is the ID column. So if the user needs to do anything with this particular record, it will be useful to have the unique identifier of the record itself. So how can we get that value back? Having got the value within the cell the user has actually clicked on, we now want to pull back the value in the other column. If we have a quick look at the configuration of our application, looking at our configuration, we can see that the column name that the user gets to see on the ID column is ID. The backend name of the column is IDX ID. Now with these configurations, the plan is that the result name will never ever change. However, the column name could change. If the user at some point later decides that they want the ID column called something different, then you can quite easily edit this value without having to edit the backend name, the result name. So any references in your code should really be to the result name, because it should never ever change. So if we copy that cell, and we'll minimize this for the moment, and we'll go back to the code. Now there's another function we can use to pull back the value in a specific column of a row of our choosing. And that function is getValueOfResultColumn. And the output from this is a string which will populate into this refID variable. We pass it the three variables we usually pass, the form, the grid, and the tab. Additionally, we pass the grid handle, the row number that we got back from this call up here, and we're also passing it the name of the column, IDX ID. And this will populate refID, which we can put into our message box to see what value has been picked up. And if we pick one of these at random, for example, record number 9, we click on that and it pulls back the name in the surname column plus record number 9. If we pick another one, we'll get record number 15, so we can quite easily pick up the value in our unique column. However, this does mean hard coding this inside your code. Ideally, we would like to create a template application, which you can copy and use as a starting point for your later applications. However, if we're starting to hard code names of columns in here, this would be counterproductive. So is there another way of actually pulling back the unique ID for a record? If we look at the configuration of our particular grid, we'll see there is a column we haven't used yet, and this is the column primary. If we tick the column primary and save this, this defines this particular column as being the primary identifier of the record. And we can make use of another function within our library instead of using the getValueOfResult column. And this function is getValueOfPrimaryColumn. This, as you will see from the parameters, takes the form, grid and tab, it takes the grid handle and the row, but it does not actually need the name of the column. Because in your configuration, you should only have one column set as the primary. While the system would allow you to tick more than one of these, you should only tick one. And it does have the advantage that since you have not hard-coded the name of your column, then this will work for any grid. So if we run that again now, we'll see if we pick on one of these, it will still pick up the ID, despite the fact we're not specifically referencing this column. It's done entirely on the fact that it's configured as the primary column. So now that we've handled the logic behind our user button, let's go on to pick up the cell altered function. This event will be triggered each time one of the cells has actually undergone a change. What we want to do is we want to highlight on the grid the fact that this particular cell has actually been amended, and we want to record on the grid that the whole row will need to be written back either to the database if we're using SQL Tools, or to our static text file if we are not. So as before, we will pick up the current row and the current column that the user has indeed amended, just as we did with the user button. And we will test to make sure that the screen is not being refreshed and that the column is not being resorted. What we will next need to do is to pick up the name of the column the user has actually amended. We can quite easily do that by using the MLG get function within the MyLittleGrids function library. It takes three parameters: the grid handle, the row number, which in this case is row 0, which is the header row, and the column our user has actually amended. Having determined the name of the column, we can use another function in our library, the getUdtColumnPosition from grid. This takes three parameters we've used before: the form, the grid, and the tab. It additionally takes another parameter, which is the name of the column as seen by the user, which we have got in this variable. So having determined the user-defined type pointer, we want to test to see whether the property of this cell is one that the user could amend or has been amended from somewhere else. We can use the getProperty function, again another function in our library, which takes our usual three parameters: the form, the grid, and the tab. Also takes the handle to the user-defined type, and it's checking the property which is column lock. In other words, is this particular cell one that is locked that the user themselves cannot actually update? If that's the case, then we exit the function because we don't want to mark this as being updated by the user. Now we get to the interesting bit. Having determined that we can now mark this cell as being updated, our next task is to make sure that the column is not the primary column, because generally our primary identifier of a record is one we won't want the user to update anyway. I'm putting an additional bit of logic in here to change the state of our toolbar. The toolbar is where our save button resides. Now when the application initially loads, my plan is to make that button on the toolbar disabled so it cannot be clicked on, because there is nothing to save. And if there is anything to save, we will re-enable that button, so it's an indication to the user that if the button is active, then there is something to save. You can do this quite easily using the toolbar setState command, passing it the handle of the form, the constant for the toolbar, the button on the toolbar that we wish to change the state of, and what you want to do. In this case, we want to re-enable the button. So having re-enabled our toolbar button, we're now going to mark on the grid that this particular row has indeed been updated. We're using another function that comes with the MyLittleGrid library, which takes three parameters: the grid handle, the row number, and a number. In this case, we're using a constant defined at the beginning of the program, which we will use to mark the record as being updated. And the final function we're going to call here in our own library is the one to mark the grid cell. This will highlight the grid cell in color. It takes three parameters: the grid, the row, and the column. So if we try running this now, and we make a change to, for example, one of our tick boxes, we'll see that having ticked on it, it appears as bright green. This is a good indication to the user that we have indeed changed the value of a cell. And the other field we can change is the department field. If we pick something else from the drop-down, it will also appear in a nice highlighted bright green color. So it will be obvious to the user here that they have a number of changes which they've made on the grid which have not yet been saved. If we were using SQL Tools, these would later be saved to the SQL Server database. If we're using our static flat text files, then they would be saved later to the flat text file. And that would happen when the user clicks on the Save Changes button. Now, one last thing I want to do today is to initialize the Save Changes button on the toolbar as being disabled. So if we go back to the initialize of the dialog, in our initialize dialog event, I'm putting another command to set the state of our toolbar. Again, the handle for the form, the constant for the toolbar itself, the constant for the save button, and in this case we're using the state disabled. So if we run our application now, we will see that when the application comes up, the Save Changes button on the toolbar is initially disabled. Therefore, there is nothing to save. If we make any change, it will be re-enabled automatically. So in today's session, we've actually shown we can mark on screen to the user which fields on which rows have actually been amended. And in addition, we've handled the event when a user clicks on a field that has a user-defined button. And when they click on the button, we have code in the event handler that picks up the value of the cell on which they have clicked and also picks up the ID column. We could, if we wished, put additional logic in to pull back every single column for that particular record. You could then in theory display that in a separate form to allow the user to actually browse this information or additional information got back from either your database or your flat text file. In our next video, we will tackle actually saving this updated information back to our database or to our flat text file. But that's it for today. Thank you for watching.